Hello, dear students. Welcome to my YouTube channel. So, in the previous lecture, we studied about the serial peripheral interface, right? In this lecture, we are going to see universal asynchronous receiver transmitter. We are seeing the communication interface. Universal asynchronous receiver transmitter comes under the communication interface. Okay. So, what is this universal asynchronous receiver transmitter? In the universal asynchronous receiver transmitter, we have one transmitting device and one receiving device. Okay, there are two devices. One is transmitter and other is receiver. Okay, and here there are two lines. First is TXD line, which is transmitter line, and second is the RXD line, which is a receiver line. Okay, now this TXD is connected to RXD. How? Why? Because see, in the transmitter there are two lines, TXD and RXD. In receiver also there are TXD and RXD lines. Now TXD of the transmitter is connected to RXD of the receiver, and RXD of the transmitter is connected to TXD of the receiver. Okay, for the proper communication, this is used to enable the proper communication. Okay, fine. So these are all about the connections. Now this asynchronous transmitter receiver transmitter, what do you mean by that? That communication is not synchronous. There is no clock signal for synchronization between transmitter and receiver. In other devices, transmitter sends a clock signal to receiver, and till the speed of transmitter matches the receiver, after that the communication gets started. Okay, here there is no clock signal. Okay, transmitter doesn't send clock signal to receiver device. Okay, fine, clear. So in this manner, we have other settings. So how the transmitter which will match up with the receiver? For that we have other settings in the serial communication. This is a type of a serial communication. Data is transmitted serially in this case. Difference between the serial communication and parallel communication is there in one of my previous videos. You can watch it. Okay, so here in asynchronous receiver transmitter, we have a serial communication. Okay, fine. Now, how does this serial communication takes place? And why it is a serial communication? See, because there are only two lines. Obviously, now you can see there is only one bus which is connecting the TXD and RXD. There are not multiple lines for transmission of each and every bit. There is only one single line for transmission. Okay, so serial transmission takes place. Initially, same line, all the bits are transmitted through a same line. Okay, whereas in the parallel communication, the different bits are transmitted to different lines, so the communication is faster. Here in serial communication, it's a bit slower. Okay, it's a bit slow. Fine. Now, how the data is transmitted? See, before transmission, there are various settings like baud rate settings, start bits, number of stop bits. Now, these settings like baud rate settings, number of a start bit, number of a stop bits should be same for both transmitter and receiver. That is, the baud rate of transmitter should be same as the baud rate of the receiver. Okay, number of stop bits in the transmitter should be same as number of stop bits and start bits in the receiver. If they are same, there is no need of synchronization. Just the settings of the transmitter and receiver should be same. Okay, I hope you're getting me here. Okay, now what do you mean by baud rate? What is a start bit? What is a stop bit? See, baud rate is number of bits transmitted in a 1 second. Okay, for example, there are 8 bits transmitted. It doesn't happen. Just assume that. Assume that there are 8 bits transmitted in the 1 second. So baud rate will be 8 because there are 8 bits transmitted in the 1 second. Okay. Now, start bits and stop bits. Okay. Before the starting of the bit stream, before the bit stream start, there is a start bit. Okay. And when the bit stream ends, there is one stop bit. So bit stream consists of the pattern of ones and zeros. Okay, it can be 1 0 0 1 1 0 and etc. A lot of different patterns of ones and zeros. They are ended by start bit, stop bit. Okay, along with the parity bit. Okay. Now start bit indicates the start of the bit stream, stop bit indicates end of the bit stream. Okay, and what is the parity? how does the data get transmitted? Now see, what happens is transmitter device adds a parity start bit and stop bit to the bit stream. Okay. Now what is a parity? Even parity and odd parity. There is one bit called as a parity bit. Now if there are odd number of ones in the transmitted data, then parity is 1. And if there are even number of ones in the transmitted bit stream, then the parity is 0. Okay, and when the receiver receives the bit stream, what exactly happens? It calculates the parity first. It counts the number of ones in the bit stream. And if the parity is 0, that is even parity, it calculates the even parity with a received parity bit. Okay, and then it compares. And if the both the things are same, then the bit stream which is received is the correct one. Okay, so in this way, now whenever there is a transfer of data, there is a possibility that because of some external error, the bit is might change and received bit stream might be an erroneous. So parity bit is an important thing. Now this universal asynchronous receiver transmitter, National Semiconductors 8250 is one of the UART chip which is manufactured, and it is a standard UART chip. Okay, fine. And this universal asynchronous receiver transmitter is integrated inside our machine or laptop which we are using. Okay, and because of that UART, we can transmit the data serially. Okay, and data transmission takes place via UART. Okay, I hope you have liked this video. If you like my video, please like, share and subscribe my channel. Thank you.